Hello and welcome. My name is Gayatri Sundarajan, and today we're here in Arlington High School in the physics classroom, and we're here to test boomilevers. Mr. Masuk, can you tell us what boomilevers are?
Boomilevers are a cantilever beam, and they are sticking out like a boom, hence a boomilever. So it's like a construction crane, essentially.
And what are the students going to be doing?
The students are attempting to hold a load at the far end of their cantilever up to a 15 kilogram mass of sand. That's approximately 30 pounds of sand. And they are allowed to use only the spindliest of pine construction materials. So the emphasis is on design, not brute strength.
We went for the typical boomilever design. If you look up boomilevers, they mostly look like this. We had this part is the tension, so it's pulling, and then here it's pushing in. And then we had to use this so that it didn't hang at an angle. And then that's where it broke because it was pushing in here, so the wood snapped here.
24 pounds.
We found this source of wood that we thought would work really well, so we kind of built it around the strength of the paint sticks, and it looks like it paid off.
At first, we had a lot of cross beams that were in the form of triangles on this part and here, but eventually we decided that we wanted to base it around the paint sticks, so we took out the triangle.
You're bending my screw!
Technically, pine paint stirring sticks are thin and they are made out of pine and therefore they are legal, but they allow you a certain advantage that a regular strip of pine wouldn't have. So I have to change the rules a bit so that I don't have my steel J-hooks being bent by 15 kilograms of sand.
So our boomlever experience was a little bit disappointing. Our idea kind of broke in the part where it didn't really have anything to do with the actual design. Do you want to talk a little bit about that?
Yeah, we focused a lot on like the triangles and like the part of that, most of the actual boomlever, but we didn't think enough about how it would be resting against the loading board. So that ended up being our flaw, which was really disappointing, but we learned from it.
What I hope students get out of it is that they see a real-life application to what we're learning in class, that it's not just rote learning and it's not just college prep. It has real-life applications and implications. You see newspaper stories and video stories all the time of bridges collapsing and people going down with them. Airplanes falling out of the sky, buildings that, like our John Hancock Tower, where the windows were popping out. Why? Because they didn't really understand the physics of how to secure the glass. These are all real-life applications of what I teach in class, and I want to establish the connections between what I teach and real life, which is critical.
Well, thank you so much. And for Arlington Public News, on behalf of Mr. Masuk, this is Gayatri Sundarajan.